Well, thank you very much. I'm very honored to be here and give you my talk. Our aim and our goal is to develop data services like the integrated AI-driven OR planning, and we really want to integrate it deeply into the business process of the hospital. AI has to make sense, and it has to create value. And I think our solution creates value for pretty much all the stakeholders, all the 4 groups. So just to give you a little background, was already introduced. Before I founded my startup, I worked in the consulting industry with Unity, and actually was very lucky that I was able to convince my former boss to invest in our idea to develop a data-driven service company. And it took me quite a long time to convince him to do that, and then we founded it together, and we are right now a complementary part of the so-called Unity Innovation Alliance, and we work together quite a bit still with the consultants. And actually, that's how we came to the whole thing with AI-driven OR planning, because Unity has a specialized group of consultants who do OR process simulations. They support hospitals when they plan new parts, new ORs, new buildings. And they draw on the processes, on the resources, and on intervention data. And they did a lot of simulations for the last 20 years. So from this, we learned a lot about how OR management works today. And OR management, how it works today, is basically dealing with rescheduling because of delays. It's dealing with placing, moving the operations. And all of a sudden, emergencies come, and they were unfortunately completely unseen. And the managers who do the OR plan, they're pretty much in a sandwich position between the hospital administration, who of course want to maximize revenue, and on the other side with the clinical staff who just want to do their job. They want to care for the patients, and actually they want to work on a reliable basis. Looking at this, we pretty much came up with a vision how OR management should look like. And I mean, now we're talking about fantasy. Yes, this is a little bit fantasy, or this was fantasy, I would say. And our fantasy was that in the OR plan, they should be real. I mean, it should be realistic, it should be robust, and I should be able to trust into the plan. And because if the plan is robust, everybody values or likes it because, for example, we can improve working conditions for the employees because we create less overtime. It's a better patient experience because we tell them to be there in the morning by 9 to receive the intervention, and yes, at 9 o'clock your intervention takes place and not by 6 o'clock in the evening. And of course, there are so many manual steps, like what I heard from the radiologists talking today. There are so many manual steps that actually take away time from the medical staff, which they actually can better invest into being there for the patients and increasing the patient care. We came up with a problem, or we stated the problem that today, OR management pretty much manually works in large parts and obviously doesn't make use of the cost-intensive resources. And then we came up with a solution, and we called the solution integrated AI-driven OR planning, or what our product's name is, nextOR planning. And basically, we installed it already in one of our customers' houses. And on the right side, you see pretty much the old world. You have an old OR plan. It's pretty much manual, of course. It's not intuitive, and of course, it does not make use of the cost resources in an optimal way. And our new solution is basically a semi-automatic OR planning, which is an AI, or like a combination of different machine learning algorithms for different parts, which I will explain later in my talk. And we, of course, use modern open web technology, and we achieve a better increase in the use of the resources today. I just wanted to tell you a little bit about what's under the hood. Already talked about that. Basically, what's behind the thing is that we draw on existing data from data holding source systems, for example, the hospital information systems. So we draw on intervention types, patient data, and patient or intervention facilitating conditions, like what kind of anesthesia do you need, what care level do we need, of course, what kind of resource do we have, what's their availability. And then we come to the first thing, and this is basically the first module, which we call the data engine. And there we come to the problem, what you said, is we draw from data, and this data is not completely good. So we have to clean it, we have to check the quality. We basically, what we already do is we pre-process and pre-calculate values for our machine learning algorithms, like the to-be time optimizer, which I will explain later on. And the data engine processes the data, stores it, and makes it available. Then we have another part, it's a business rule engine, which we supply, I would say, the human intelligence to the thing, because we don't know all the things from the data, and there are just some guidelines which we have to take care of. And that's basically like a set of rules which is highly individual for each hospital. And then the basic idea of making a better and more robust plan is to be able to calculate a more robust to-be time value. And in the today's or our plan, you basically come and work with mean values. And basically what you say, look at, and you know, this kind of intervention, I have knee surgery, and this takes on average 90 minutes. But when we look at the data, you quickly see that there's a large variance in to-be times. And it depends on exactly all the impact factors which we look at. For example, what's the patient? Is it an old guy? What kind of allergies do they have? And so on. And so the to-be time optimizer does the first thing. Basically, it predicts on an individual intervention level how long does it really take, or will it really take. So basically what we do is, I try to explain it always like, we try to determine, is it like this, or is it like this, or is it like this? And what we do later on is, next to this, the external impact module, which determines or predicts how many buffer time do we need for the next day, for the next week. And of course, it's a problem where we look at historical seasonal data, but also we look at external data. What's the weather? How many COVID-19 patients will come in? Haven't included this yet, but nevertheless, that's the idea of it. And you provide all the information to basically the scheduler. And the scheduler is pretty much doing, a lot of simulations and tries to, play Tetris in an optimal way. Just to drill down there, the to-be time optimizer, we have an interface. You can look at the dashboards, and what we do is, overall, we achieve a decrease in the prediction error, or in actually the error between what was planned and how it really took place, on average 40%. And of course, over the time, we increased the to-be time optimizer all the way. Like when we actually came up with the first, productive running version, I would say, like in September, we started at like 19-80%, and now, as you see, we're right now like at 40%, and I think it's getting better and better because, of course, we learn from every new data which is coming in, and you already see in like the plastic surgery department there, where we score very bad in comparison to our average score. And of course, we had a deeper look into it and looked, how does it come? And pretty much it comes because the patient data, which the plastic surgery team supplies, is bad, or it's incomplete. There's way less data, and the data is not really qualitative. And on the other side, we have other departments which supply very good data quality, and where we are way better in predicting to-be times. And on average, you see this like 104% is great. We can be very good if we have very good data. So basically, the better structured data you get, the better the prediction performance will be. And when we start to make it transparent to the people that this really has a big impact in how we are able to calculate the times and all the way through how robust the plan is and how much money you can do or how you can reduce overtime, then they realize might be good to invest 5 minutes to type in the data in a structured way. The scheduler, what we do is, like in the production version of our software, you basically have a plan. You don't see the AI. You see the output of the AI, but it doesn't look anything different than a manual plan, of course. And how we try to introduce the way we think to the whole team is that we have like a period where we show both the manual plan, which is still in place, and our AI plan, which we calculate, but they don't really use it in this time. And we already tried to show you how was the plan, the manual plan, how would the AI have planned the day, and how did it actually really happen that day? Oops. And just some examples here. I mean, in the middle, it's always like in the top bar is always like the manual plan. The middle was then our AI plan, and the bottom line is how it actually took place. So you can see, for example, AI estimated the durations much more accurate, and as a result, for example, on that day in that room, there might have been another operation regarding value that would be maybe increase of revenue. The other thing is, again, data quality. On the bottom example, emergencies were known 2 days before. In reality, the emergency was known, but actually planned too late in the manual plan. The AI knew it because it was registered, but it wasn't planned. So we did a way more or better plan, so we could have reduced overtime. On the other side, we do errors too. The AI is not perfect. There might be complications. We didn't know or we don't know about complications because they are not provided to us in a way, like the data about the complications are not provided us in a way to us that we actually can make use of it. So we are blind on this thing, and we are not able to predict that this kind of intervention in this combination with this patient will probably have complications, which result in a longer intervention time. And another thing is at the bottom example, like New Year's Eve, so not a lot of operations planned there. We did know when the doctor was there, so we knew the availability, but the doctor came in early. Actually, it started earlier than we have planned, but we were on the other side way more exact in the prediction of the to-be time. And well, this were just examples. What we then did to analyze our the schedule performance was we did a simulation. We simulated the manual plan versus our nextOR AI plan. So, we compared, we defined the several KPIs. We said we defined KPIs regarding plan execution, and we defined KPIs to rooms and actually to surgeons. And we then performed 1,000 rounds of simulations with site probabilities, 1% probability of an emergency, 5% probability of a planned operation being canceled, 1% probability of an operation taking place in a room other than planned, 1% probability of an operation being carried out by a surgeon other than planned, 100% probability of an operation starting and ending earlier or later than expected. And came out with these kind of results. This black is the AI plan, and green is the benchmark or the existing system. And we came out and we were able to show that in a historic view, we were able to achieve really a higher room utilization, resulting in increase in revenue. And we were able to come out with more accurate start times, which increases the robustness of the plan, more reliable working times for the staff, more reliable times of the patient. And these results, they were so good and convincing that our development partners actually decided that we are now going into a real-time evaluation phase, where we, starting in mid-March now, where we will actually be able to plan or use the plan, our AI-based plan, for 2 of the 18 rooms, and over a period of 3 months, and actually evaluate how it performs in reality.